National Electrical Code Article 300.37c vertical supports for conductor states that medium voltage conductors shall be securely supported at intervals not exceeding 20 feet vertically and as closely as practicable to a point of connection to a circuit breaker, transformer, switchgear, or other equipment. Therefore, the maximum length of unsupported 12 kV NV cable from the conduit stub up to the fastening point is 20 feet, as per National Electrical Code Article 300.37c. This requirement is crucial for ensuring the safe and reliable operation of medium voltage electrical systems. Understanding the specifics of this code section is vital for any electrician or engineer working with medium voltage cables. The code aims to prevent excessive stress on the cable termination and to maintain the integrity of the cable insulation. When installing medium voltage cable, it is essential to adhere to these vertical support requirements. The 20-foot maximum interval helps to distribute the weight of the cable and prevents it from sagging or pulling on the termination point. This sagging can lead to stress on the cable insulation, potentially causing premature failure or even electrical faults. The phrase "as closely as practicable to a point of connection" emphasizes the importance of providing support near connections to equipment like circuit breakers, transformers, and switchgear. These connection points are often subject to mechanical stress and vibration, so additional support is necessary to maintain a secure and reliable connection. Failing to properly support medium voltage cable can have serious consequences. Firstly, it can create a safety hazard. An unsupported cable can sag and potentially come into contact with other objects, leading to electrical shorts or even fires. Secondly, it can reduce the lifespan of the cable. Excessive stress on the insulation can cause it to degrade over time, leading to premature cable failure. Thirdly, it can violate electrical codes, which can result in fines and penalties. To ensure compliance with National Electrical Code Article 300.37c, it is recommended to carefully plan the cable installation and to provide adequate support at the specified intervals. This may involve using cable trays, clamps, or other support mechanisms to securely hold the cable in place. It is also important to inspect the cable installation regularly to ensure that the supports are still in good condition and that the cable is not sagging. When calculating the maximum unsupported length of medium voltage cable, it is important to consider the weight of the cable and the pulling tension it will experience. Heavier cables may require more frequent support intervals than lighter cables. Additionally, if the cable is being installed in an area with significant vibration, it may be necessary to provide additional support to prevent fatigue failure. Remember to always consult the manufacturer's recommendations for the specific type of cable being installed. The manufacturer may have additional guidelines or requirements for supporting the cable. It is also a good practice to consult with a qualified electrical engineer to ensure that the cable installation meets all applicable codes and standards. The NEC is updated regularly, so it is important to stay current with the latest requirements. Changes to the code can impact the way medium voltage cables are installed and supported. By staying informed and following best practices, you can ensure that your medium voltage cable installations are safe, reliable, and compliant with the National Electrical Code. Specifically referencing Article 300.37c helps to highlight this exact requirement in an effort to point to the literal requirements set forth by the NEC. There can be other implied factors involved with cable supports and cable support systems for any voltage of electrical service for safe installations. As with all electrical installations, one must be aware of the safety considerations that go into it. Firstly, lockout-tagout procedures should be followed at all times. Secondly, you should use appropriate personal protective equipment such as gloves and eye protection. Thirdly, use properly rated tools. Working on electrical equipment can be hazardous if proper procedures are not followed. When running medium voltage cable, it is imperative to consider several factors beyond just the vertical support requirements. These factors ensure safe and reliable installation. Firstly, cable selection is crucial. The cable must be rated for the voltage, amperage, and environmental conditions of the installation. Secondly, proper termination techniques are essential. Improperly terminated cables can lead to insulation failure overheating, and even electrical faults. Thirdly, cable routing should be carefully planned to avoid sharp bends, which can damage the cable. Cable bends have limitations to the amount of degrees that they can be bent safely for the cable to operate at the intended voltage. Fourthly, the cable should be protected from physical damage. This may involve using conduit or other protective measures. Another consideration when installing medium voltage cable is grounding. The cable shield must be properly grounded to prevent voltage buildup and to provide a path for fault current to flow. This grounding is essential for safety and for the proper operation of protective devices. Also, consider the ambient temperature in the area where the cable is being installed. High temperatures can reduce the ampacity of the cable, so it may be necessary to use a larger cable size. In addition, consider the presence of corrosive materials. If the cable is being installed in a corrosive environment, it may be necessary to use a cable with a special jacket. These special jackets can be more resistant to harsh chemicals. Also consider the potential for water damage. If the cable is being installed in a wet location, it may be necessary to use a cable that is specifically designed for wet environments. These can be made with special insulation that reduces the likelihood of water damage causing a fault in the cable. Also be aware of the location of other utilities. Before digging or drilling, it is important to locate any underground utilities to avoid damaging them. This is extremely important as medium voltage cable is typically buried in certain applications. Failure to do so can result in serious injury or property damage. After the cable has been installed, it should be tested to ensure that it is working properly. This testing may involve performing insulation resistance tests, voltage drop tests, and other tests. It is highly recommended to always test after the installation is complete. Ensure the cable installation is documented. This documentation should include the cable type, size, length, routing, and termination details. This documentation will be helpful for future maintenance and troubleshooting. When working with medium voltage cable, it is important to remember that safety should always be the top priority. By following proper procedures and taking the necessary precautions, you can ensure that your cable installations are safe and reliable. Proper installation of medium voltage cable is vital for safety and reliability. It's not just about meeting the minimum requirements of the NEC, but also about considering the specific conditions of the installation and taking the necessary precautions to protect the cable and the people who will be working around it. Always remember to use qualified personnel. Medium voltage cable should only be installed by qualified electricians who have been properly trained in medium voltage cable installation techniques. Working with high voltage electricity is dangerous and should not be attempted by untrained individuals. Additionally, ensure proper planning before you start the installation process. Before starting the installation process, carefully plan the cable route, support locations, and termination points. This will help to ensure that the installation goes smoothly and that the cable is properly supported. Another consideration is to use the correct tools. Use the correct tools for the job. Medium voltage cable requires specialized tools for cutting, stripping, and terminating. Using the wrong tools can damage the cable and lead to safety hazards. Also, follow manufacturer's instructions. Always follow the cable manufacturer's instructions for installation. The manufacturer's instructions will provide specific information about the cable's properties and how to properly install it. Don't overload the cable. Make sure that the cable is not overloaded. Overloading a cable can cause it to overheat and fail, which can lead to fires and other hazards. This means you need to have proper overcurrent protection in place. Maintain proper clearances. Maintain proper clearances around the cable. Medium voltage cable must be kept away from other objects to prevent arcing and other hazards. This also means maintaining proper clearances from other energized equipment. Inspect the cable regularly. Inspect the cable regularly for damage. Damaged cable can be a safety hazard and should be repaired or replaced immediately. Also, keep the cable clean. Keep the cable clean and dry. Dirt and moisture can degrade the cable's insulation and lead to failure. Ensure you are following grounding practices. Ground the cable properly. Medium voltage cable must be properly grounded to prevent voltage buildup and to provide a path for fault current to flow. Additionally, use cable supports. Use cable supports to support the cable. Cable supports should be properly spaced and sized to support the weight of the cable. Additionally, use cable markers. Use cable markers to identify the cable. Cable markers should be placed at regular intervals along the cable route. And document the installation. Document the installation. The documentation should include the cable type, size, length, routing, and termination details. Also consider cable training. Provide cable training to personnel who will be working around the cable. Cable training should cover the hazards of medium voltage electricity and the proper procedures for working around medium voltage cable. Finally, perform routine maintenance. Perform routine maintenance on the cable. Routine maintenance should include inspecting the cable for damage, cleaning the cable, and tightening connections. By following these best practices, you can help to ensure that your medium voltage cable installations are safe, reliable, and long-lasting. This ensures that the electrical system performs according to the intended design. Safe working conditions, reliable electrical service, and code compliance are all critical to an electrical installation.